Now let us see head recursion. See, this is a structure for head recursion. If there is a function that is calling itself, so it's a recursive function, then the first statement inside the function is recursive call. It is calling itself here. Then what all the processing it has to do, it is doing it afterwards, after the recursive call. So there is no statement, no operation before the function call. See, if there is something here, then it is not a head recursion, right? If something is there before the function call, just it is a recursion. We don't have to give any special name for that one. So there is nothing before that one, then we can say this is a head recursion. So what do you mean by head recursion? It means the function doesn't have to process or perform any operation at the time of calling. It has to do everything only at the time of returning. So all the processing is done at returning time. Then such functions are head recursion. So the example of this type of recursion already we have seen in the previous video. This was the simple example. So you can see that the function is first calling itself, then the second statement it is printing. So the printing will be done at returning time. So the function doesn't do anything at calling time. So such recursions are head recursion. Next, we will compare head recursion versus loop. Can we convert them into loop? Let us discuss this. I will try to write the same function using loop. So let me write here void function fun. Now instead of conditional statement, I have to write a loop that I already have shown you. So if n greater than 0. Now here first it has to make a recursive call, then it is printing. So if you remember the output of this one, the output of this function was 1, 2, 3, as it's going to print at returning time. So if you remember the answer in the previous video, or else you can check back, the result of this type of function is 1, 2, 3, because it is printing at returning time. Now as it is, I have tried to write the function with a loop. Now I want the output to be 1, 2, 3. So if I use printf here, printf %d n, then if I am passing function fun with value 3, then first value of n will be 3. So 3 is greater than 0, yes. So it will print what? 3. It will not print 1. First value that will be printed will be 3. It is not 1. Then if I have to repeat, then just like this one, instead of that if I write n minus minus, then it doesn't work same as that one. So you cannot easily convert it. So you have to write it in some other way to get the same output. But as it is, looking at the function, if you try to convert, it's not easy. We can write some function which prints 1, 2, 3 using loop, but looking at this function, we cannot directly create it. So it means I have to write it in a different way. So let me write it. Suppose I have to take some variable I, and that is value 1. Then I should say I is less than equal to n. Then here I should say I plus plus, and I should make this I plus plus after printf. So let us try to run and see this one. If I pass the value as a 3, that is n is a 3. So I is 1, 1 is less than 3, so it will print I, that is 1. So output is 1. Then I becomes 2, so 2 is less than 3, so it will print 2, so result is 2. Then I plus plus, I becomes 3, so 3 is less than equal to 3, so I is 3, so it will print 3. Then I plus plus, I becomes 4, 4 is not less than equal to 3, so it will not enter in, and it will finish the loop and it will come out. So the output is 1, 2, 3. So that's it. You can see that that function cannot be as it is converted. So head recursions, or if a recursive function has to do something at returning time, it cannot be easily converted in the form of a loop, but it can be converted. It doesn't look as it is. So that's all about head and tail recursion. In the next video, we will see tree recursions.